26 years ago, colleagues of the current research crew left tracks on the seabed. Today, the scientists will find out if they're still visible. Tracks in mud. After 26 years? In the deep sea, this is not as absurd as it seems. This autonomous underwater vehicle, known as an AUV, is meant to clarify if this is true. It will take thousands of photos of the seabed to do so. Later, the computer will put these photos together in a large mosaic, another piece of the puzzle to help us understand the deep sea.
The staff on board, the biologists and geochemists, also want to see what has changed biologically in 26 years, or what has changed geochemically. And then we want to use that to make a statement on how quickly the deep sea would regenerate after mining has taken place, and how intensive the damage would be at all.
The images will answer these big questions. Will these tracks still be visible? The scientists wait impatiently for the underwater vehicle. The expedition has brought one surprise after another. Experts had all presumed the seabed was even. However, in fact, the researchers on the Sonne have discovered it's full of hills and valleys. These will complicate mining the nodules. The computer slowly puts together a mosaic from the images of the seabed. After 26 years, the tracks from the ploughing harrow are still just as clear as if they had been made yesterday. But how bad is that? That's where opinions differ.
There are also investigations in shallow waters at the shelf where icebergs really plough through the seabed. They leave iceberg plough marks which are considerably larger than the small scratches that we make. They create a relief in the seabed sometimes of several tens of meters in height difference, and life blossoms there.
But will it be like that in the deep sea? The researchers want to take a ground sample from the place the ploughing harrow swilled up sediment 26 years ago. This will give them an idea of whether the seabed has changed or regenerated. The output of the gravity corer is very precise work.
Can you move the ship 5 meters to the north again?
Finally, the right position has been found, and the gravity corer sinks 4 kilometers down. If it is not lowered down onto exactly the right part of the ground, the sample taking will not be successful.
Winch stopped.
Winch stopped. The ship is now in the right position.
Lab bridge, okay, I'll be in touch. Generally, in manganese nodule mining, the upper 5 to 10 centimeters of the sedimentary soil are taken away or significantly damaged, which didn't happen as intensively with the ploughing harrow. That means that the fauna, or the animals that live in them, will die or be removed completely. The bacteria will be similarly affected. This means that this depletion of organic material, the consumption of nitrate and oxygen, will be reduced or will completely disappear.
Nicht so in dem Maße oder ganz verschwunden sein.
How big is the damage caused, and how far does it continue to the deeper layers of the seabed? Answers to this are to be found in a several-meter-long sediment core from the seabed. Matthias Heckel is examining samples from various depths. The sediment core operation was successful. On board the Sonne, many staff members help out when a task needs to be completed quickly. The team quickly brings the core to the cold storage room in order to take out individual samples. Due to the ploughing harrow 26 years ago, oxygen got into areas in which it usually doesn't occur.
The first results that we can see, primarily relating to the oxygen profile, is that oxygen can freely penetrate into the sediment. The microbial activity in the surface sediment is still significantly damaged after 26 years. I had expected that the microbial activity would have been able to recover more quickly.
Damaging geochemical processes in the ocean can signify a dangerous interference. The seas are giant CO2 storage spaces. They absorb CO2 from the air. It's partly bound in plankton and sinks to the ground. It's partly transported by streams deep underwater and can stay there under certain conditions for centuries. An additional part is given back to the atmosphere from the surface.
Because of its large surface, the seabed, especially in the deep sea, is the great motor of our global carbon cycle. It's the great stabilizer of our climate on a timescale of around 100,000 years. In addition, there is a second cycle that we come into contact with when we operate in the deep sea, and that is oxygen. At the end of the day, the floor of the deep sea stabilizes oxygen levels. We're now talking about a timescale of around more than 2 million years.
The seas are more than 4 billion years old. They emerged on a planet full of volcanoes. People are not able to overturn the elemental forces of the oceans in a day. As the first rains fell, they created the foundations for the oceans we have today, and thus made life on our planet possible. Processes that we set in motion today could have effects in thousands of years.
Well, essentially, you can say that the experiment that was carried out here in 1989 provided the findings that when mining is carried out extensively, there is a lasting detrimental effect on the environment. And regarding the regulations that are now to be created by the international seabed authorities, it shows us very clearly that how much and how coherently areas are allowed to be mined must be somehow regulated.
The industrialization of the seas is moving at an unstoppable pace. Aside from the territories of individual countries, the open ocean belongs in principle to nobody and to everybody. The International Seabed Authority was created in 1996 in order to protect the seabed. The researchers on the Sonne work in conflict between environmental protection, politics, and economics. The economic side is even on board with them, in the form of Johannes Post, the CEO of the Deep Sea Mining Alliance, a merger of businesses who want to promote deep sea mining. Even Post thinks that the Seabed Authority needs to take swift action.
The mining regulations really need to be written and implemented over the course of the next 1 or 2 years. Because there are already companies around the world, and also countries, who want to start with initial tests imminently. So it must be clearly stated somewhere where exactly the regulated boundaries stand.
The authority has its headquarters in Jamaica. It grants licenses for the manganese nodule belt. Companies are not able to apply for licenses, only countries are. Whoever is granted one is able to initially start exploring the area and later to mine the natural resources. This also applies to the tiny island state, Nauru. The people in Nauru see deep-sea mining as a chance for economic prosperity. Consequently, the government agreed to an offer from the company Nautilus Minerals to apply collaboratively for a license to start exploring.
None of the small, poor states were really very interested. Until then, large companies came and said, "You have the ability to get a license area. We'll organize everything for you and you'll be our sponsor state. And we will then manage the mining, including the exploration. You'll have no costs and you'll even be paid for your license."
But does it work as simply as that? The islanders already once experienced sudden riches from natural resources and a subsequent crash. Not even 40 years ago, Nauru was one of the richest states in the world, so rich that the government didn't impose any tax. On average, every citizen owned 3 cars for 29 kilometers of tarmac road on the island. The wealth of Nauru's came from one single resource: phosphate. Since the year 2000, the resources have become almost completely exhausted. Nauru plunged almost overnight to the status of a developing country. Since then, the island has withdrawn from the contract with Nautilus and wants to extract manganese nodules independently. Will that bring renewed prosperity?
The question is ultimately, how much really goes back to the population? What does a third world country get from it when they get mined by a large Western company? That leads to the danger that only a small percentage of the upper class in the country gets the money, and the rest of the population get maybe 2 or 3 additional schools, and that's it. Jobs will certainly not be created in these countries because the positions needed demand highly specialized understanding of the deep-sea mining business, and these staff are just not available there.
When filling the roles for the job, again, only the large industrialized states get a chance. Germany, France, Belgium, and other EU countries. Russia too. Yet it is questionable where these countries will process the nodules.
There is just as high an amount of waste as in land deposits, because at the moment at least the international legislation on the high seas states that the leftover slurry may not be put back, so the disposal needs to be taken care of on land somehow. And well, for me, as industrialized countries, that's a point that we have to really think about, where we want to smelt these manganese nodules in the end.
Latin America is not far, and to get the manganese nodules all the way to Germany would not make sense economically. But none of the Latin American countries that come into question also have anywhere near the same environmental standards as the EU states. And the non-ferrous metals can be thoroughly poisonous for humans. Could countries like Germany make sure that the smelting of the nodules does not make people here ill and increase the misery? And that our prosperity and growth does not trigger an ecological crisis? In 2077, we'll know the answer. Presumably, those responsible would have chosen the easiest path. In this case, mining the nodules would have brought the industrialized countries non-ferrous metals for a few more decades, and would have given nothing to the people of Latin America. In 2077, the aging research ship, the Sonne, sails again in the manganese nodule belt. Now it is fully automated. The state of the seabed has surpassed even the worst fears of the researchers of the past. The diving robot meanders through the destroyed wasteland. At least, some animals have dared to return to the area after mining was given up. Even in 2077, we can't yet say how the damage to the ecosystem will affect the climate. Millions of years will go by until new manganese nodules form. They are by no means a renewable resource. Should they be mined anyway? Even the researchers reach different conclusions.
It's a huge resource that is deep down in the ocean. And if I mine something on land, I also make a very large impact that could influence humanity more directly than if I do it under the sea. Ultimately, it's a question for society as a whole. Do we want to touch everything that we have the technical capability to? Or do we want to progress a little in our actions and move towards methods that really are regenerative? Before we now approach a new resource in the ecosystem that is essentially important for the whole planet, for which we cannot accurately assess the consequences.
Who decides on the priority? Deep-sea mining has a financially powerful lobby. The seabed doesn't.